analysts are very siloed by discipline or by specific tool, and having different ways to visualize and different ways to share and collaborate is really what's needed. You need to have that to enable the collaboration, and then some of the successes you have make it grow.
I think also, just to add on that, one of the things that we saw here a lot is the fact that the way that the output data is represented needs to be understandable by more than the discipline that created it. So if you have an NVH person come up with the results of their simulation, and then that's usable by someone else for another kind of validation or simulation, then that gets people collaborating naturally. You don't have to force them to do anything. What companies are starting to do is create teams of people where some are perhaps the experts in the product and how customers use it, and others are experts in the tools. And so bringing those people together is going to start this collaboration and broadening effect of simulation in general. But I think that's also a way that the teaming is a way of getting multidisciplinary optimization out of those silos. Well, that wouldn't be multidisciplinary, but out of getting the simulation out of the silos and into a more collaborative, more multidisciplinary way. And I think that that's just a reality that companies face and they all have to deal with in some way.
Well, and the other thing that your tool and some others have dealt with is, the thing about simulation is every simulation, the geometry has to be dealt with differently and prepared differently. And that's a big barrier to having multidisciplinary is if you have to prepare it separately and do that multiple times, it's just a lot of effort. So the benefits of your tools in that area is going to be very important.
By trying to create a management structure where you're using the CAD model that is versioned in some way with the simulation data input that is versioned some way with the solver that you used, with the output that you created, with maybe the multidisciplinary optimization technology set up the process that you used, you have to start capturing all of the versions and traceability for that to make sense later on. How can you know if a design fails why your process didn't catch that? Unless you keep track of the versions and how they're all put together. So SOMO integrating with PDM or PLM products is a great way of getting that started in companies. But I think it's another one of those areas that still needs a lot of maturation within the CAE departments to become something that really takes off and grows. The maturity level of MDO, I think, is very high in some companies, but much lower on average. I think that the very sophisticated simulation companies who've been doing simulation of some sort for a long time understand the idea of MDO and the benefits of MDO and have been with it since the tools were very, very difficult to use. I think other companies that did not start this a long time ago still think it's very difficult to use, and so they're a little bit afraid of getting started. So I think there are two tiers of maturity, in my experience.
You know, a lot of the companies that we work with tend to be on sort of the right side of the V, where they're still trying to get their handle on validation, whereas MDO is really more of a front side of the V. It's more of a graduate level topic, and again, tools like you're providing are something that are going to help people.
You know, looking at the way that people were using modeFRONTIER over the last 2 days, the reason to use it is so obvious. The proof points are so strong that I think as the rest of it falls into place, it's going to be a much faster growing area.
Right, and what tools like yours and others do, the word democratization was used. By letting the experts use their expertise to set up the problems for analysis, and then having a more simplified user interface, you're going to bring the power of those tools to more people.
SOMO by itself is very powerful and very capable and meant to be used by experts right now, but apparently future versions of SOMO will be able to be simplified so that people who are not experts can get involved in using optimization to the level that some expert says that they should. And I think that technologies like that, techniques like that will really cause it to have much broader applicability than it does now. You need to be an expert now to do it and understand the results. Maybe later on, someone will simplify the things you can do down to a manageable set, and someone who is not an expert can run an optimization that gives a good result and then understand that result.